still in the process of getting our feet wet with organic chemistry, and we've realized that this is getting pretty hectic because there's so many different varieties. Each time we add one, we add numerous more. We can have single bonds, alkanes, double bonds, alkenes, triple bonds, alkynes. I am repetitive, I know, but trust me, you're very soon going to hear those words and it'll come very easily to you. So let's just carry on with a little bit of theory first of all before we go further. We have got different ways of writing this. We can have what we call a molecular formula. Okay? Basically, that is going to be things like C4H8. So it means it's got, I always do C4, I put in singles, then H8s. Okay? Now I've got to find, how do I put H8s? Okay, so I say 1, 2, 3, 1, 2, 3. Now it means H8 means I can have those H's there, okay, like that. Then I have to work out my bonds, and you can see 3. So I'm going to have a double bond in there, and 1, 2, 3, 4, like that, right? Or a double bond in the 1, 4, because I must have 4 bonds around each carbon, all right? And I've got 4 there. Now, when we start to look at the molecular formula, that's what we're used to. All right. So there's various forms, and we saw a few as we went past earlier. Now, there's another formula. Okay, we can write it as a structural formula. Guys, this is I personally believe this is the best. The structural formula is in fact that. It's when you do the carbon with all its sticks and its bonds and everything else, like so, 1, 2, 3, 4, and like so. So that's going to be C3H1, 3H4. C3H4, right? So, because I've got 4 bonds there, 3, 4 bonds, and that, right? So now, oh, hang on, you can actually name this. This is an ein, it's a 3 bond, so it's an ein, right? That's its thing. And we say, aha, it's got 3, so I label from here, right? The end next to the functional group, the family name, the ein is there. So it's a 1, right? And it's meth eth prop 1 ein, 1 propyne. All right? Straightforward, not tough at all. Okay, the structural formula, I like it because when you're given anything in whatever form, it to me makes a lot of sense. I can see it as a picture. I try and use the structural formula as much as I possibly can because, as I say, I can rub out stalks and make them singles, doubles, triples. Okay, it sometimes gets a bit messy trying to work it out with the other formulas because you don't know where this stuff goes. Okay. Structural formula. The next one we're going to look at is we're going to say condensed formula. The condensed formula. Okay, that is going to be written CH3. I've just got one CH and a double bond CH and a CH3. Okay, like that. It's condensed. What does that mean? It means I've got a carbon on this side with 3 hydrogens. Okay, I like to draw it. I'm attached to another carbon. Why? Because I have to be. It's an organic molecule, which means the carbons have to link up. Nothing else, just the carbons. Carbons link up. I've got one H on him. Then I've got a double bond with another carbon and an H there. Then I continue, all right, with a C and an H3 there. All right, so the condensed formula is, how do I write it? I start, okay, and I write it down going through. But if I have, can you see here? I haven't written anything. Let me just put it in green. There and there. That means it's a single bond. You don't show those. You only show where the doubles or the triples are in the formula. It could have been over there, a different thing altogether. All right? How would we label this thing? How would we name it? we would say this is going to be, all right, it's a alkene. So we would say it's an ene. All right, first of all, because a double bond, that shows it's an ene. Second, we say 1, 2, 3, 4, meth, eth, prop, bute. So it's bute. Okay, and it's on number 2. 1, 2, 1, 2. It's the same both way. Bute 2 ene. Okay, now let's move along. Okay. That's the condensed formula, the structural formula. That you're going to be asked to write them out as that. I can only recommend that if you've got the condensed or the structural, use that first, all right? Because if you get CH, that starts to get a little bit difficult because you're not sure where there's double or triple bonds. You actually have to work it out. And it can become very time consuming. Just a warning on that one, all right? Okay, now, remember we said to ourselves, okay, condensed structural, okay. So how do we do this stuff, all right? And we're asked to name it. We're just going to stick with a hydrocarbon just for the moment, all right? So let's put in this one here. Let's take a hydrocarbon, all right? First of all, we find the functional group, okay? Let's just write down some steps. Step 1, find or identify functional group. Right? That is single, double, or triple bond carbon to carbon. All right? That makes it an ane, an ene, and an ine. Don't worry, we're going to add other stuff on. We're going to add some chlorines. We're going to add oxygen on there, okay? I don't think in our syllabus here we add nitrogens, but we're going to add oxygens. We're also going to add an OH on it to make an alcohol. Okay, so an ane, an ene, or an ine is what we're going to put in there. So that step 1 is we identify that. Step 2, all right, is, okay, defines what it is. That's the surname, all right? So that does that. Count the number of carbon atoms. Count carbon atoms, okay, and label longest chain. 1, 2, 3, 4, 5, etc. All right. Start at the end closest to functional group. All right. Now, what does that mean? That's pretty straightforward. Let's have a look. Let's say I've got this here, CC, triple bond C. Okay, that's going to mess up now. Can't have a triple bond there. Okay, because I can't. Yeah, I can. 1, 2, 3, 4, then onto a C and a C and a C. All right, so I've got that there like that. Now I've got no hydrogens on that, no hydrogens on that, and we've got that. Okay, I've just hydrogens on the outside. I'm just going to save time. I'm not going to put them in every time. Okay, so just pretend this is all hydrogens over there on those, right? Now, so therefore, step 1 is I identify what is the surname of this functional group, which means it's an ine. So I put down ine. Okay, then I say, okay, how many carbons? Count them. 1, 2, 3, 4, 5. There's 6. So it's going to be a hex. 6. But I label it from the end closest. 1, 2, 3, 4, 5, 6. Right? Hexane. Can you see I labeled it from here? Because that was the end closest to the thingy. There it is. So I now have to say where it is. It's on number 2. Okay, so that's very straightforward. Very straightforward indeed. The next step is to say, all right then, we've got those. Well, what about if we now say to ourselves, let's just look at this then. What if I do this? Remember we went back and we had this guy. I think I had 5. Let's just look at him. Now you can say, right, that is meth, eth, prop, but, pent, and it's all singles. So it's going to be, first of all, an ane. It's all an ane, so I don't need to label at this point. And therefore, it's going to be pentane. Now, remember, we had this guy. Okay, we had this, didn't we? Right. Always check that you've got 4. Kevin often leaves them out. Okay, like so. So we've got all our H's around there. Remember, this was an isomer of pentane, wasn't it? So what did we do now? Now we said, okay, first of all, find the longest chain. There it is. Okay. Okay. Second, now we say, okay, it's all single bonds, so it is an ane. Right? The next step is to say, okay, there are 1, 2, 3, 4 in the longest, so it's meth, eth, prop, but. Butane. Okay? So this is basically a butane. The green is a butane. Is it not? So the green part is the butane. But it's got something stuck onto it. These we call, I did them in blue. This we call a side chain. All right? Now you label this longest chain from the closest to the side chain. So it's butane, but it's got a Christian name because there's a prename. It's got a side chain attached to it. All right? The side chain is attached at number 2, and it's a single one, so it's got its own name. It's a C like that. This is the side chain, and that is called a methyl. So it's 2-methyl butane. Because it's butane and, okay, butane, all singles, ane, meth, eth, prop, but, 4, therefore it's a butane. And then I look at the side chains attached to it. You'll see how this methodology starts building up as they get more difficult. Now the next one that we had under that series, we had this guy. Whoops, changed to black, sorry. Just get that like this. So the next one we had was like that. Remember I added Kevin's getting ahead of himself again. I added it like this, right? Like that. Now, it doesn't matter which is the longest chain. So I'm going to just say, for example, just for a change, take it as down. All right? And then we said, right, they are all single bonds, therefore it must be an ane again. So I say, right, you are an ane, and you are meth, eth, prop. And I don't need to have a surname, so I call this, or a double barrel, nothing there, because it's propane. Now I label my longest chain because I have got 2 side chains. There's one, and there's one, sitting over there like that. So what do? I say, all right, these 2 side chains, identify them. They are both methyls, and they are on number 2. Okay? So therefore, I have got now I have a little column for my side chains. Okay? I have got a methyl on 2, and I've got another methyl on 2 as well. All right? So therefore, I have got 2 methyls, which makes it called a dimethyl. Because when you have more than one, it's called a dimethyl. Okay? And you have to tell me where they are. They are 2 and 2 dimethyl. Okay? It's, in other words, there's a methyl. This is why I like to make a little separate thing of my surname is done. I like to make a little list of all the little prenames that come in front of it. All right? And on 2 and on 2, I've got a methyl, so it's a dimethyl. Yes, you can have 2, 3, 4 trimethyls as well. We're going to see some of those now. But just let's get the hang of this. Okay. Let's look now and say we have, okay, we've got but2ene, we've got that. What do we do about this? Here's one. Here's another example. C, double bond C, C, double bond C. Okay? Right, so now I say, okay, 1, 2, 3, 4, 1, 2, 3, hydrogen, 1, 2, 3, hydrogen, 1, 2, 3, 4. Okay, I'm just drawing it with some symmetry. Okay, unless somebody is very pedantic at this stage, if you put the hydrogen at the bottom or at the top, it doesn't really make a big difference. Okay, we're not into the levels of deciding which side it goes. All right, so how do we name this? First of all, we say, right, what is it? It's double bonds, so it's an ene. All right, carbons 1, 2, 3, 4, meth, eth, prop, bute. Okay, so I say it's 4 carbons, therefore it's a bute. But now look, I have to label it. So I label from it doesn't matter. It's symmetrical. So 1, 2, 3, or 4, or 1, 2, 3, 4, it doesn't matter. I'll do another one of these just below it. Okay, so we say, okay, in other words, my actual thing is bute, but I have got 2 functional groups. Okay, there's 2. There's 2 enes. There are 2 enes. This is an ene, and this is an ene. So therefore, it's bute. Right, now, you have to tell me, remember where we are. Bute 1, 3, and diene. So let's rewrite it. Let's just go through it again. So it's bute, okay, and it was an ene. But there's 2 enes, so I call it a diene, because there are 2 enes. There they are, 1 and 2 of them. I can have a triene as well, yes. Okay, so it's a diene. And where are they located? You have to tell me where. They are located on 1 and 3. Okay, bute 1, 3, diene. All right? Okay, bute 1, 3, diene. Okay. Let's have a look at another one of these. All right, I'm just going to move the bonds. So double bond, and another one. What the heck, put in another one. So double bond, there's 4. There's 3, so there's a hydrogen. There's, to make up my 4, okay, there's that there like so. All right, and I'll do this one completely. I've got everything right, so now let's name it. All right, whoops, kooky dookie. All right. There it is at the top. So first of all, I say, right, what is it? It is an ene. There are 2 enes. There are 2 ene. Ene number 1 and ene number 2. Therefore, it is a diene because there are 2. 3, triene. Okay. 4, tetra. Okay. 5, penta, hexa, blah, blah, blah. So that's a diene. Means there's 2. But now you have to tell me where they are. They are on, we label from the end closest to the functional group, 1, 2, 3, 4, and 5. So it's 1 and 2, because there's an ene on 1 and an ene on number 2. And lastly, I have to say how many carbons? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is pent. Pent 1, 2, diene. Okay. Pent 1, 2. Pent, there's 5 of me. 1 and 2 means something's attached to 1, something's attached to 2. And diene means there's 2 enes across the board. Right. We can now continue. We can say, let's look at side chains. Right? Let's put the same one, all right? Let's take this one here. Side chains are things that fit, they are attached to the longest chain. Remember, we identified the longest chain as that, and we said our side chains are going to be blue bits and pieces, but now we can add loads of different stuff onto them, all right? Because this chain can be quite long. We can add stuff onto it. Now, if we add one of these, I'm just going to give you a few. If this is, now these are all attached to a carbon. This is attached to a main chain here. Okay? This one is called a methyl. Okay? If I attach this, okay, that is called an ethyl. You can see it's all attached to my long chain. Okay? This chain could be like 20 carbons going that way. Okay? These are all added on. They are side chains or branch chains. Okay? So we go and we then say, all right, methyl. I could also have 3 carbons attached, like so, like so. That's methyl ethyl propyl. Meth eth prop, methyl ethyl propyl. The next one is going to be butyl, okay, etc. Okay, butyl, meth eth prop, pentyl, hexyl, da 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 da. Okay, we're not going to get up to hexyl added into it because then the main chain is going to get too long again. So let's see what happens with these then. How do we number this? So we say, all right, I want to draw C double bond C, single bond C, double bond C, and I'm going to put my hydrogens in. I can have 2 hydrogens here. 1, 2, 3, 1 hydrogen there. I can have 1, 2, 3, 1 hydrogen there, and I've got to have 2 hydrogens over there. Now that's the basic makeup, but on this one, instead of there being a hydrogen added there, we added a side chain. It's also called just let me, give me a second. You will also see this as a CH3, a C2H5, a C3, and it's going to be H3, 4, 5, 6, H7. All right? And it's going to be a C4H, okay, 3, 5, 7, 9. Right? Because if we've got 4, I'll have 3, 4, 5, 6, 7, 8, 9 of them. Okay? Sometimes you'll see that when it's written in the condensed form. Okay? And you'll see brackets around it with a 2. So you could see on the condensed, you can see CH3 with a 2. It means there's 2 methyls, 1 each side. But we'll get to that. So over here we say step 1, identify the longest chain. There it is. Identify the functional groups. There they are. So now we're going to label this 1, 2, 3, 4. Because I changed it now, okay? Because I'm labeling it now, remember it's symmetrical, but this guy is on number 2. I'm trying to keep that number as low as possible, okay? So if we start to label him, we're saying to ourselves, here we go. We say, okay, this is double bond, which means it must be an ene. That's step 1. Locate double bond is that. The longest chain is 1, 2, 3, 4, meth, eth, prop, bute. Bute. And on 1 and 3, it's a diene because there are, sorry, go back to green. Here's an ene and here's an ene. So it's a diene because there are 2 enes. And the ene, the double bond, is located on carbon number 1 and carbon number 3. The next step is I say, right, my side chains. Okay, there we go. So I have a little column here, side chains, all right, and I say that I have got a methyl on 2. So therefore it becomes 2-methyl bute 1,3-diene, like so. 2-methyl bute 1,3-diene. Okay? Very, very difficult to get the hang of this. It takes a lot of practice. That's all I can tell you. Takes a lot of practice. Okay? So I've got that. What did I do? I tried to, I labeled it from there, but I kept my side chain number as low as possible. Okay. Now, we're just going to do, more side chains can be added. Let's take a look at this guy then. All right. Wait, just erase you. Okay. What I'm going to do, okay. What if we had this? See, wait. What if we had one that looked like this? C, like that. Okay. And then over here, I've got a C, and over here, I've got a C, and maybe over here, I've got a C and a C, and over here, I've got a C and a C. So let's have a look at what this would be. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Let's make it safe like that. Okay. Now, here I've got found my longest chain. Now, please be careful. Okay. I'm going to, I think, do examples just now where the chain can be zigzagging through. You have to find the longest uninterrupted carbon chain. So can you see here? There we go. 1, 2, 3, 4, 5, 6, 7. Okay. And 7 hex septa, I think it is. We'll get to that now. Don't worry. 1, 2, 3, 4, 5, 6. I'll actually take one off to make it a hex. All right. Like so. Okay, that's what our carbon chains. Now I'm going to just put on my hydrogens. Okay. There's a method in my madness for doing it like this. I wanted it to be a hex for a particular reason. I'll show you. Okay. So now let's just check 1, 2, so I can have 2 hydrogens here. And I've got to put in an H there and an H there and an H there. There's a C, an H like so. This is what it's going to look like, right? C and another bond over there. Whoops, sorry, with an H. Da, 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 da. Okay, like so, with an H here. Come on, Kevin. H, right, H, H. And we just check, have we got everybody connected? So I chose the longest chain as that one. Can you see I could also have chosen to have gone 1, 2, 3, 4, 5, 6. I could have gone down that way as well. So I could have had a green chain. My green could have done that. Okay. It doesn't make any difference. Because you'll see why. Essentially, that's 2 C's that are added on as a branch chain, isn't it? The branch chain this way is exactly the same. So now I'm going to say, find my branch chains. Blue. There's a branch chain. There's one. There's one. There's one. All right. So now let's work on this. Step 1. This is going to have, what are my functional groups here? I have got an ene and another ene. So I have got here a diene, haven't I? Diene. Okay. Don't worry, this is your working area. You can write it all very neatly when you've finished. Diene. And I label from the end where the functional group is. So I'm going 1, 2, 3, 4, 5, 6. Can you see I could have gone 5, 6 that way? It would have just made that a side chain. Same side chain. So it's a diene. I have to say where they are. They're on 1 and 2. Then I say it's 6, so it's a hex. Hex 1, 2, diene. Now I make up my list of side chains. Okay? Side chains. All right? And on the side chains, on 2, I have got a methyl. On 3, I have got a methyl. On 3, I have gotten ethyl. And on 4, I have gotten ethyl. Now we have to put those side chains in, okay, into the name itself, right? So we know it's a hex 1,2-diene, all right? Okay. Now I have to put the side chains in. There's a rule for this too. You put the alphabetical. So it's 3,4-diethyl, because on 3 and 4, I've got one. You have to tell me where everything is. On 3 and 4, and there's 2 of them. They're not on the same one. Diethyl means there are 2 ethyls, and this is a dimethyl, because there are 2 of those. 3,4-diethyl, 2,3-dimethyl. This is in alphabetical order. E comes before M. So the ethyl before the methyl. All right? So 3,4-diethyl, 2,3-dimethyl. That's basically how we put them in. Hex 1,2-diene. Okay? What a flippin' thing, huh? Okay, next we're going to now practice some more, but we're going to now start looking at, instead of just a hydrocarbon, we're going to add other elements on and other ions onto the actual chain itself. It's not very difficult, okay? We're only going to add a halogen, we're going to add an oxygen, and we're going to add an OH, all right? Okay, I'll see you in the next one, and we'll continue with this. Once you start getting the hang of it, it's actually very rewarding, I promise you. Cheers, I talk too much. I'll see you later. Bye.